Good morning, student. So we have already studied all the topics of this lesson. So now you know how to solve the quadratic equation, how to find the root, and how to solve the word problem based on quadratic equation. Okay, now you know everything. So in this video we are going to start the problem set 2. Okay, now question number 1 is choose the correct answer for the following question. Means you have MCQs. So MCQs is your homework. Okay, and from the MCQs, question number 6 is omitted from the syllabus, so no need to write question number 6 from the MCQ. And question number 10, find the quadratic equation such that its roots are. So question number 10 from the word problem. Okay, so question number 10 and question number 6 from the MCQs is omitted. Okay, so no need to write this question in the textbook. So we are going to start the question number 2 first. So what is in the question number 2? Which of the following equation is quadratic? So you know the definition of a quadratic equation. The highest degree of the equation should be 2. Okay, so the highest degree of variable should be 2. Then only you are going to call it as a quadratic equation. Okay, so this is the one line answer. So you will get in the notes, and directly we are moving to the question number 3. Now what is given in the question number 3? Find the value of discriminant from each of the following question. Okay, so we have to find the value of discriminant, and question number 1 is 2y square minus y plus 2 is equals to 0. Okay, so value of discriminant. So first we are going to compare this with the standard form of the quadratic equation. So this we have to find. So comparing with the standard form, ax square plus bx plus c is equals to 0. Your a value is 2, your b value is minus 1, and your c value is 2. Now what is value of discriminant? It's your delta, which is equals to b square minus 4ac. This you have to find. Okay, this is a sign of value of discriminant. So substitute the value, you will get minus 1 whole square minus 4 into 2 into 2. Minus, square of minus is always positive, so you will get 1 minus 4 2s are 8, 8 2s are 16. 1 minus 16 is minus 15. Okay, so your value of discriminant is minus 15. Sign of bigger number. Okay, this is how you are going to solve the question number 3. Now question number 4. So in question number 4 they have given you, if one root of the quadratic equation is 2, find the value of k. Okay, so one of the root is 2 means, and they have given you the quadratic equation. Question number 4 is 2x square plus kx minus 2 equals to 0, and if one root of the quadratic equation is 2, one root of the quadratic equation 2 means your x value is minus 2, so they have given you x value is minus 2. Find the value of k. We have to find the value of k. So what we are going to do? We are going to replace x with the minus 2. So substitute x is equals to minus 2 in the given quadratic equation. So you will get 2 into minus 2 whole square plus k into minus 2. Minus 2 is equals to 0. 2 into minus 2 square is 4. plus minus 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 2k minus 2 is equals to 0. 4 2s are 8. 8 minus 2k minus 2 is equals to 0. Okay, 8 minus 2, sign of 8 is plus, so 8 minus 2 is 6, so you will get 6 minus 2k is equals to 0. Shift this minus 2k over here, so you will get 6 is equals to 2k. Now this is in the multiplication form, so this 2 will go in the denominator and it will divide the 6, so you will get, therefore k is equals to 6 upon 2, k is equals to 3. So value of k is 3. This is the solution of a question number 4. Now question number 5. Two root of a quadratic equations are given. Frame the equation. So in question number 5, we have to frame the equation and they have given you the value of root. Right? So we are going to solve question sub question 2 from question number 5. So they have given you 1 minus 3 under root 5 and 1 plus 3 under root 5. Clear? One is alpha, another one is beta. So these are the root of a quadratic equation. So we are going to take let alpha is equals to 1 minus 3 under root 5 and beta is equals to 1 plus 3 under root 5. Okay. Now to frame the quadratic equation, first we have to find the alpha plus beta. So alpha plus beta is 1 minus 3 under root 5 plus 1 plus 3 under root 5 plus minus cancel, 1 plus 1 is 2. So your alpha plus beta is equals to 2. Now we are going to find the alpha into beta. 1 minus 3 under root 5 into 1 plus 3 under root 5. Now this is in the form of a minus b into a plus b, and this is the identity a square minus b square is equals to a plus b into a minus b. So we are going to use that identity. So you will get a minus b. Okay. You will get 1 square minus 3 under root 5 whole square. 1 minus 3 square is 9. 9 and root 5 square is 5 only. So 9 into 5. 9 into 5 is 45. So you will get minus 44. Remember this. So your alpha plus beta is 2 and your alpha into beta is minus 44. Okay. So your alpha plus beta is 2 and your alpha into beta is minus 44. So next step is we have to frame the equation. So the required quadratic equation is x square minus alpha plus beta x plus alpha into beta is equals to 0. Substitute the value, so you will get x square minus 2x plus minus 44 is equals to 0. So your final equation is x square minus 2x plus minus 44 equals to 0. So this is how you are going to frame the quadratic equation by using the given root alpha and beta. Now question number 6. Determine the nature of the root for each of the following quadratic equation. So you know how to determine the nature of the root. If the value of discriminant is less than 0, if it is negative, then the roots are not real. If it is greater than 0, then it is real and unequal. And if it is equals to 0, then the roots are real and equal. Okay. So if the value of discriminant is equals to 0, it is real and equal. Greater than 0, it's real and unequal. And if it is less than 0, then it's not real. Okay. So I'm just going to solve one question from this question, sub question 2. Root 3x square plus root 2x minus 2 under root 3 is equals to 0. After doing a comparison, right, comparing this with x square plus bx plus c is equals to 0, so you will get a is equals to root 3, b is equals to root 2 and c is equals to minus 2 root 3. Okay. Now we are going to find the value of discriminant, means your delta, which is equals to b square minus 4ac root 2 square minus 4 into root 3 into minus 2 root 3. Okay, root 2 square is 2, minus minus plus 4 2s are 8 into root 3 into root 3 is root 3 square means 3. 8 3s are 20. So 2 plus 24. Answer is 26. Okay, now 26 is greater than 0, means your delta is greater than 0. Therefore, the roots are real and unequal. Okay. So this is how you are going to find the nature of the root. Right, the process is same. You have to find the value of discriminant, and you know, if it is greater than 0, then it's real and unequal. Less than 0, then it's not real, and if it is equals to 0, then it is real and equal. Now question number 7. Question number 7. Solve the following quadratic equation. See the first one. 1 upon x plus 5 is equals to 1 upon x square. Okay. X is not equals to 0 and x plus 5 is also not equals to 0. You have to solve this quadratic equation. So first we are going to do the cross multiplication. So you will get x square equals to x plus 5. Shift this. So you will get x square minus x minus 5 equals to 0. Now you are going to compare this. Compare with ax square plus bx plus c equals to c2. Okay. So your a value is 1, your b value is minus 1 and your c value is minus 5. Now we are going to find the value of discriminant, means b square minus 4ac. So we'll substitute the value, minus square minus 4 into 1 into minus 5. So you will get 1 minus minus plus 5 4s are 20, 21s are 20, 20 plus 1 is 21. So b square minus 4ac is equals to 21. We know the formula method. Okay, we know the root value. So what is root value? X is equals to minus b plus minus under root b square minus 4ac upon 2a. Okay, now we are going to substitute the value of b and b square minus 4ac. So you will get we have a is equals to 1, b is equals to minus 1 and c is equals to minus 5. Okay, minus minus 1 plus minus under root 21 and b square minus 4ac under root 21 upon 2 into 1. Minus minus plus, so you will get x is equals to 1 plus minus under root 21 upon 2. Right? It means two roots are x is equals to 1 plus under root 21 upon 2 or x is equals to 1 minus under root 21 upon 2. These are the roots of given quadratic equation. Okay, so this is how you are going to solve the remaining question of question number 7. Okay, I hope you all understood this.